Trig derivatives is something we need to kind of go over real quickly in a video. And basically what we've come up with in class is you can prove these a long way. You can prove them with your calculator, which is kind of an informal proof. But if you just memorize them, life will be easier. So there's 6 trig derivatives that we're working on currently, and they're all the basic ones. So the typical functions that we know are sine, cosine, and tangent. So we should commit these to memory. If I want to derive sine, I should know right away that the answer is cosine. So the way I'm going to write that out is I'm going to write dy dx equals cosine of x. And you just need to remember, sine always derives to cosine. That's kind of one of the easier ones to remember. Cosine's kind of the opposite. If you derive it, dy dx, you end up getting a negative sine of x. It's a negative sine of x. In fact, all cofunctions, if you derive them, give you a negative answer. So just kind of keep that in mind. And then tangent of x, if we derive it, dy dx, it's secant squared. So in all reality, if you can remember these 3, then the other 3 are kind of easy. They kind of follow a similar pattern. So let's go down here and look at the other 3. The other 3 are secant, cosecant, and cotangent. So this is 4, 5, and 6 that you have to commit to memory. And we'll just kind of cruise through these a little bit. Secant, the derivative dy dx, is secant of x times tangent of x. So secant times tangent. Cosecant's kind of the opposite. It's a cofunction, so it's got a negative derivative because it's a cofunction, and it's kind of like this one, but it's cosecant of x times cotangent of x. So just a little bit different. And then the last one, cotangent, the derivative, again, it's a cofunction, so it's going to have a negative derivative. And it's the opposite. Tangent is secant squared, so cotangent is cosecant squared of x. And those are the 6. So commit them to memory, flashcard them, memorize them, do whatever you can. You're going to have little pop quizzes all the time in class on these because you just got to know them all year long. So those are the ones we're going to focus on. So let's do some examples of applying these a little bit. And we'll start off with our first example here. Often there's not a lot of work to show on these. So if I told you I had f of x equals 3x squared plus the sine of x, you're just going to derive it straightforward. Like this is a power rule problem and this is a memorized problem. So f prime of x equals this thing being power ruled, so it's going to be 3 times 2 is 6x, plus sine, we're just going to memorize, is cosine, so cosine of x, and that's it. You're done. That's your derivative. So you can see where some of these, like, there wasn't a lot of work to show. Start the problem, derive it in my head, get my answer. They can get a little more complicated. Like, don't get me wrong, they're not all straightforward. So some of them, let's say you get something like this, like w of x equals 4 cosine of x tangent of x. You can't go like directly to your memorized rules on this one. You can't just be like, oh yeah, cosine is negative sine and tangent is secant squared. Unfortunately, it doesn't work. This means we have 4 cosine of x times the tangent of x, so we're multiplying, so we need the product rule. This is totally a product rule problem. So, product rule. So in this case, here's our first, and tangent of x is our second. So we're going to go through that memorized product rule now. You can see where all these things that we have to memorize kind of start to overlap. And we're going to find our derivative. We're going to do the first times the derivative of the second. So the first is 4 cosine of x times the derivative of the second. So tangent, we've memorized, is secant squared of x, plus the second, tangent of x, times the derivative of the first. 4 cosine, it's going to become a negative sign, so it's going to be times negative 4 sine of x would be my derivative. use parentheses when you have a negative sign. If you don't put a big parenthesis around this, it's going to look like you have tangent of x minus 4 sine of x, which is not what you have. It's being multiplied. So let's rewrite this because it doesn't look good right now. It's not in a nice format. I don't have to clean up all these trig things. I can leave it as 4 cosine of x times secant squared of x plus, or maybe I should have made it a minus because of the minus 4. So negative 4 tangent of x sine of x. And you can either stop, call that your answer, or if you want to use some trig rules and you want to cancel some stuff out, you want a simpler answer, you can do that too. Trig rules would be to say, oh, let's make secant squared 1 over cosine squared of x. It's the same thing. That would be something we could do. And we have 4 cosine of x times this thing minus 4 tangent of x. Tangent is really the same as sine over cosine, so sine over cosine times the sine of x equals w prime of x. And you could cancel, the really only things that are going to cancel is the cosine and one of these. Here you can do sine times sine is sine squared, but it's not going to do you a whole lot of good. So what I'm going to do is I'm going to say, okay, now I have 4 times 1 over cosine, which is secant of x, minus 4. This thing, I don't really think it'll be simpler, so I'm still going to call it tangent of x, sine of x. And I'll call that my answer. W prime of x equals, the derivative equals, this thing. But honestly, in all reality, if you were on a test and you weren't totally sure, or you want to just stop and you wanted to call this your answer back here, you could have. They're mathematically the same. So you get to choose how far you want to go with these problems. Sometimes it helps, sometimes it's not necessary. So check this next one out. Let's say for the next example here, you get y equals secant of x over cotangent of x. And you want the derivative. You want to derive this thing. So what rules are we going to have to apply? Well, we're going to have them memorize trig rules. And it's secant divided by cotangent, so it's a quotient rule. We have a division problem. So we got two things going on here, memorized and the quotient rule. So my derivative, dy dx, the derivative of y, is going to be the bottom times the derivative of the top. So the bottom is cotangent of x times the derivative of the top. So the derivative of secant is secant tangent, so secant of x, tangent of x, minus the top, secant of x, times the derivative of the bottom. So the bottom is a cofunction, so we're going to have a negative derivative, so let's put a big bracket or parenthesis around this negative derivative. And cotangent is cosecant squared of x. All over, look how nasty this one is, the bottom squared. So cotangent squared looks like this, cotangent squared of x. That's how we write the bottom squared. It's technically done. This could be your answer, but I'm going to clean it up because things are going to cancel. Things are totally going to cancel. So cotangent and tangent are opposites. Cotangent is cosine over sine, and tangent is sine over cosine. So technically, those are going to cancel. So that's kind of nice. So I have secant of x. That's kind of nice. They cancel. Okay, so, and then we have these two negative signs that I'm going to make into a positive. And then secant and cosecant squared, this is 1 over sine, this is, or 1 over cosine and 1 over sine squared. I'm not going to do anything with that. I'm going to call it secant of x, cosecant squared of x. There's just no need to. All over the bottom squared, cotangent squared of x. I think I'm happy. I'm going to leave it like this. I could go farther, I think, but it's a good answer. So I'll leave it like that. It's really these negative signs that I just want to make sure I always clean up so they don't come off as the wrong answer, basically. So that's trig in a nutshell. It's really short, but you got to memorize those 6 rules, and then product rule and the quotient rule are still going to crop up every once in a while. The big thing that people kind of get confused by the last thing we're going to do for this video is when there's a number with the function. So like y equals, how about 5 cosecant of x? A lot of people aren't totally sure what to do with the 5. When it's just a 5, then go ahead and just leave it there. So cofunctions have a negative derivative, so I'll change it to a negative 5. And cosecant, we know, is cosecant times cotangent of x. So y prime, my derivative, is going to be this thing. So don't let that number out in front really bother you. Just leave it be. It's fine to be there. It's totally different if I had given you, I lied. I said we were doing one more example. We're doing 2. It's totally different if I had given you y equals 5x cosecant of x. Once I throw a variable in there, new story. Now I've got 5x times cosecant of x. It's a product rule problem. There's a first and a second going on here. So you need to product rule this piece. Here's your first, here's your second. You can get a majorly different answer, really. So y prime equals the first times the derivative of the second, which is negative cosecant of x cotangent of x, plus the second cosecant of x times the derivative of the first. 5x is 5. So see how these are different problems. If it's just a number, it's really easy. If it has a variable, then you got to use the product or the quotient rule. Clean up the negative sign, so make it a negative 5x cosecant of x cotangent of x. And move this 5 in front so it looks a little better. 5 cosecant of x. And now I'm good. I'm not going to go any farther and cancel anything. I'm going to leave it be. There's my answer. So pay attention to the numbers in the front of the trig functions. If it's a number alone, no problem. If it has a variable, look out for product and quotient rule. They're going to show up a lot. Okay, I hope that helps. See you in class.